Fusion Mobile, quality e-learning experience on the go.
Okay, are you there? Today we are taking on energy quantization. I hope your library is going on well and reading is moving on fine. I wish you the best in every exam you write, and I wish you a very best of the lecture we are going to have now. So let's go in. Energy levels in an atom. As we know, that atom is made up of both the nucleus, which is the internal part of the atom, and the shell. At the shell, we have different shells, K, L, M, N shells, different shells or orbitals. These levels, in each shell column, there is a different energy level. Then we'll have the Frank and Hess experiment, which I would like you to look into properly. Before we go into that, let's look at types of spectra. We have the one which we call the emission spectra, and we have the absorption spectra. The emission spectra most at times help us to dictate our counting on radiation. Also even the absorption spectra. Okay, let us go in proper on thermionic emission. This is the emission of free electrons from the hot metal surface. The energy required to cause this emission varies from metal to metal. If you keep a metal on a very hot surface, after a while electrons will be emitted from that surface. So when there is emission of electrons as a result of high temperature through a metallic surface, we consider that thermionic emission. Maybe it's right I use a diagram to illustrate that. If I have this, for example, to be a metal, and down here we have fire burning on my burner, at a time this metal will start changing color, and before you know it, there will be a movement of electron from this particular metal, and when it gets here from the surface, it flies out, and this is an electron down there. There are energy that is causing this. From the metal we'll have what we call the work function, and here we'll have the kinetic energy. While the total energy, when is photoelectric emission, we consider the photon because it's coming from light. But this one around, we consider the heat energy, which heats up this to bring that particular thing to space. Properties of X-ray. X-ray pass through many materials, more or less unchanged. It causes fluorescence in materials such as rocks, salt, calcium compounds, or uranium glass, and affects photographic plates and cannot be refracted. Yes, it cannot be refracted in an empty space. Are not affected by magnetic and electric fields. Discharge electric field bodies by ionizing the surrounding air. The seventh one there on the slide, it can cause photoelectric emission and are produced when a beam of high energy electrons strike a metal target. Maybe the next lecture will handle the production of X-ray, so that you see how X-rays are being produced. Uses of X-ray: we can use it for diagnostic purposes, we can use it for therapeutic purposes, all in medical aspects of life. We can also use it to determine atomic spacing in crystals. For example, determining a crack in an oil pipeline. So after that, we'll move over to electrical conduction through liquids and fluids, which we call electrolysis. But before then, as I promised you in the next class, we'll handle the production of X-ray. But I would like you to pick up your textbook and read up the production of X-ray. Thank you and have a wonderful time.